All right, so we're diving deep into light therapy, not the stuff you see at the spa, but light as a nutrient at the cellular level.
Okay.
Got some seriously fascinating research here. Makes you wonder, right? Like, do you ever think about light being more than just, well, light?
It's so easy to take it for granted.
Yeah,
But,
yeah.
you know, light is energy. And the idea that it can, like, impact our biology at a deeper level,
Uh,
it becomes, much more plausible when you think about it like that.
exactly. And what we're looking at here, the research suggests it's not just about vision, We have light receptors all over our body, not just in our eyes, like
Really?
opsin 3 receptors on fat tissue. When those get activated by light, it can influence fat metabolism. Isn't that wild?
It is one of those things that makes you realize just how interconnected our systems are.
Yeah.
But I think it's important to say, as with a lot of emerging science, we're uncovering a lot of these mechanisms, and the clinical implications are still being explored.
So true. We need that research to back up the excitement. Speaking of going deeper, let's talk about mitochondria. Those tiny powerhouses in our cells that generate energy. I always thought of them as kind of static, just doing their thing.
The efficiency of our mitochondria,
Hmm.
how well they're actually generating energy, can vary quite a bit. And that variability directly impacts our metabolism, how we're burning fuel, how much energy we have. It's a very dynamic process.
Okay, so that makes sense. So where does light fit into this whole energy production picture?
Well, think about this. Red and infrared light. Because they have longer wavelengths, they can penetrate deeper into the body than other types of light, so they can reach our muscles and organs and even like deeper tissues.
Hold on, so they're not just hitting the surface of our skin. That's kind of mind-blowing.
Yeah, it really opens up a whole new realm of possibilities. Now, within our mitochondria, there's a complex called cytochrome C oxidase, and it plays a really crucial role in the electron transport chain, the process that ultimately generates energy.
Right, I remember that from biology class. It's been a while, so... What makes cytochrome C oxidase so special in the context of light therapy?
Cytochrome C oxidase is especially good at absorbing red light. And when it does, it enhances its activity, boosting energy production. It's like giving those little mitochondrial powerhouses a turbocharge.
Wow. It's like our cells have this built-in mechanism to harness the power of light. Makes you wonder how much we haven't discovered yet.
Exactly. And there's another layer to this that's even more mind-boggling. Do you know that water itself absorbs red light?
Really? I mean, I know we're mostly water, but I never thought about it like that.
Well, some researchers believe that this absorption could be influencing the dynamics of energy production within the mitochondria. Think about it. The mitochondria are essentially these tiny, intricate machines with spinning parts.
Right. I'm picturing those little spinning turbines.
Exactly. So imagine if the water surrounding those turbines became less viscous, less sticky. Those turbines could spin more efficiently, leading to greater energy output.
And red light, by interacting with water molecules, might be influencing that viscosity.
It's not just directly powering up cytochrome C oxidase, it's potentially optimizing the whole environment within the mitochondria.
That's the theory. It's this complex interplay of factors. And we're still piecing it all together, but it's incredibly fascinating, wouldn't you say?
Absolutely. It makes me think about all those athletes who swear by red light therapy for recovery and performance.
Well, that's a great segue to the next part of our discussion. There have been human studies looking at the effects of red light therapy on exercise performance, and some of the results are quite intriguing, but we'll delve into that after a quick break. So we were just talking about red light therapy in athletes. It's actually been gaining some traction in the sports world, with claims about faster recovery and reduced muscle soreness, even enhanced performance. Yeah. I've seen those like red light panels popping up at gyms, and even some physical therapists are using them, but does the science actually back up those claims?
That's the million-dollar question, isn't it? And the research is still evolving. But there have been studies, some more promising than others. One that caught my eye looked at the effects of red light therapy before exercise.
Before exercise? That's interesting. Most of what I've heard is about red light for like post-workout recovery.
Right. But in the study, participants who received red light therapy before exercising actually showed increased endurance and a higher VO2 max, meaning their bodies were better at utilizing oxygen.
Wow. So they were able to push themselves harder and for longer. That's pretty significant, especially for endurance athletes. I wonder what mechanisms could be at play there.
Well, one theory is that red light therapy helps to reduce oxidative stress, when we exercise. Our bodies produce these reactive oxygen species, which can cause damage to cells and contribute to fatigue.
Right. I've heard about oxidative stress. like in the context of aging and disease. But I didn't realize it played such a big role in exercise performance, too.
It's a factor that often gets overlooked. But if red light therapy can help mitigate that oxidative stress, it could explain those improvements in endurance.
Okay, so we've got this potential benefit for endurance, potential impact on fat metabolism, possible boost to mitochondrial efficiency. It's a lot to take in. But are there any downsides to light therapy? I mean, can you get too much light?
That's a great question. And I think it's important to be cautious. Just like any intervention, light therapy needs to be approached thoughtfully. There's a lot we still don't know. Not all studies have shown positive results,
Yeah.
which highlights the importance of using the right protocols.
I guess it makes sense. It's not as simple as just blasting yourself with any kind of light and hoping for the best.
Exactly. Factors like the wavelength of light, the power of the device, the duration of exposure, these all matter. It's not a one-size-fits-all approach. And just like you wouldn't take a medication without understanding the dosage, the same principle applies here.
That makes sense. But how do you know what the right protocol is? Seems like there's so much conflicting information out there.
It's true. There's a lot of noise. That's why it's crucial to do your research. Look for evidence-based protocols. And ideally, consult with a healthcare professional who understands light therapy.
Good point. It's easy to get swept up in the hype, but sometimes you need that expert guidance to navigate those complexities.
Absolutely. And it's not just about finding the right protocol, it's also about the quality of the device itself. Just like you'd invest in a good mattress for better sleep, or quality running shoes to avoid injury.
You're totally right. I would never buy the cheapest running shoes just because they're on sale. I would do my research and make sure they provide the right support and fit.
Well, the same logic applies to light therapy devices. Investing in a quality device that uses the appropriate wavelengths and power and flicker rate is essential. You're not just buying a gadget, you're investing in your health.
I appreciate that analogy. It really highlights the importance of being like discerning consumers,
Yeah.
especially when it comes to our health. So, where do we go from here? We've covered a lot of ground, but it feels like we're just scratching the surface.
You're right. There's so much more to explore. Remember earlier when we mentioned photobiomodulation?
Mhm.
That term encompasses a vast range of applications beyond what we've discussed so far. Different wavelengths of light can have different effects,
Yeah.
and research is constantly uncovering new possibilities.
Oh, right. We've mainly been focused on red and infrared light, but I remember reading something about blue light therapy
Right.
being used for skin conditions like acne.
Exactly. Blue light, with its shorter wavelength, has a different mechanism of action. It's been shown to be effective in killing certain bacteria, which is why it's used for acne treatment. The great example of how specific wavelengths can be targeted for specific therapeutic purposes.
That's amazing. And I bet there are other wavelengths being studied too.
Absolutely. It's a dynamic field with ongoing research.
Of course.
For instance, there's growing interest in green light for its potential anti-inflammatory effects and even its possible role in pain management.
Wow. It seems like the possibilities are endless. I'm starting to see why people are so excited about the future of light therapy.
It's a field ripe with potential, that's for sure. And it's not just about treating disease. It's also about optimizing health and enhancing well-being.
It almost feels like we're at the dawn of a new era in healthcare, where light could play a central role.
I share your enthusiasm. It's an exciting time to be following this field. But I think it's important to remember that we need to balance that excitement with a healthy dose of skepticism. As with any emerging technology, there will be hype and overblown claims.
Right. We can't lose sight of the importance of rigorous research and evidence-based practice. Speaking of research, I'm curious to hear more about that N=1 experiment you mentioned earlier, the video creator's decision to track his own biomarkers while using red light therapy. That's pretty fascinating.
It is, and it speaks to a growing trend of individuals taking a more active role in their own health and well-being. But before we delve into that, let's shift gears for a moment and revisit that study we were discussing about red light's effects on water viscosity within the mitochondria.
Okay. I'm intrigued. We talked about the theory, but is there actual scientific evidence to support it?
Well, there was a study published in Scientific Reports back in 2015 that provided some compelling data. They looked at the effects of red light on cell proliferation and ATP production, which is the primary energy currency of our cells.
Okay. So they were looking at how red light might impact those fundamental processes of cell growth and energy production. What did they find?
They found that exposure to 670 nanometer laser light, which falls within the red light spectrum, increased both cell proliferation and ATP production.
So The red light actually boosted both of those processes. That's pretty impressive. Did they offer any explanation for how this might be happening?
Their findings specifically pointed to changes in the viscosity of water surrounding the ATP synthase, the molecular machine responsible for producing ATP.
Wait, so they're saying that the red light is somehow making the water less viscous, allowing those ATP-producing turbines to spin more freely.
That's their hypothesis. They propose that this reduced viscosity could be a key mechanism by which red light enhances energy production at the cellular level.
That's incredible. It's like they're providing a glimpse into the intricate workings of our cells and showing how light can influence those processes in ways we never imagined.
It's truly remarkable, and while more research is needed to confirm these findings and fully elucidate the mechanisms, it opens up a whole new avenue for understanding how light can impact our biology.
It makes you wonder what other hidden connections we might uncover as we continue to explore this field.
Exactly.
Yeah.
And that's a perfect segue to the story of the video creator and his personal journey with light therapy. Are you ready to dive into that?
Absolutely. It's not every day you get to hear about someone conducting their own N=1 experiment, especially someone so deeply immersed in the science. Let's hear it. So this video creator decides to become his own experiment. I have to admit, that's a level of dedication I don't think I could match.
Yeah, it's certainly a bold move. But remember, he's coming at this from a scientific perspective.
Yeah.
Treating himself as a single subject case study, an N=1 experiment. He's being very meticulous about his approach, which is key for any self-experimentation.
I'm curious about the specifics. What kind of data is he planning to gather? Is it just subjective feelings, or is he going for like hard measurements?
He's going for both, which is smart. He's planning to use a high-quality red light therapy device, specifically the EMR Tech Inferno, and track a variety of things. He mentioned getting regular blood work to assess things like lipid levels and other metabolic markers. He's also going to be wearing a continuous glucose monitor to track his blood sugar fluctuations throughout the day.
That's a lot of data points. It's like
Yeah.
he's turning himself into a walking laboratory. But I imagine the subjective experience is important too. How is he planning to factor that in?
He's going to be keeping a detailed log of his energy levels, mood, sleep quality, and any other noticeable changes. It's a holistic approach, combining objective data with subjective experience to get a more complete picture of the potential effects.
Makes sense. If you're feeling more energetic or sleeping better, that's valuable information, even if it's not captured in a blood test. Going back to the device choice, the EMR Tech Inferno, is there anything special about that one?
He mentions that he selected it based on recommendations from experts in light biology who considered factors like wavelength, power output, and flicker rate. He also points out that it's a bit more expensive than some other devices on the market. But he emphasizes that when it comes to your health, investing in quality is crucial.
He makes a good point about investing in quality. It's like the old adage, you get what you pay for. But I'm also impressed that he sought guidance from experts. I imagine that's crucial for designing a safe and scientifically sound experiment.
Absolutely. He's not just winging it. He's being thoughtful and methodical, which is essential when you're dealing with something that can have biological effects.
So this is all well and good, but what's the bigger point? Why should our listener care about one guy's self-experimentation?
It's not just about one guy. It's about the spirit of exploration and the potential for personalized health optimization. He's essentially pioneering a path that others can follow, albeit with caution and expert guidance.
I see what you mean. It's like a case study in biohacking, but with a strong emphasis on scientific rigor. It's empowering to think that individuals can take a more active role in their own health discoveries.
Exactly. And his experiment, even though it's just on himself, could provide valuable insights that contribute to the broader field of light therapy.
It's like citizen science in action, but with a high-tech twist. And who knows, maybe his findings will inspire others to do their own N=1 experiments, always in consultation with healthcare professionals, of course.
That's the beauty of science. It's a collaborative process, driven by curiosity and a desire to understand how things work.
Well, this has been quite the deep dive. We've gone from the basic science of how light interacts with our cells to the potential benefits of light therapy, the importance of using quality devices and evidence-based protocols, and even the exciting world of personalized self-experimentation. It's truly amazing to think that something as simple as light could have such profound implications for our health and well-being.
It's a testament to the interconnectedness of nature and the incredible complexity of our own biology. And it underscores the importance of staying curious and open to new possibilities.
So if our listener is walking away from this deep dive with one key takeaway, what would you say it is?
I would say it's this. Never underestimate the power of light. It's not just what allows us to see the world. It's a fundamental force that can influence our biology at a deep level. And as we continue to explore the science of light therapy, we're likely to uncover even more amazing possibilities for healing, optimizing, and enhancing our lives.
It's a reminder to stay curious, keep exploring, and maybe even get a little bit of sunshine every now and then. Thanks for joining us on this illuminating journey.